Alright, this is the gravity ball explanation. I always think the camera's there, but it's actually there. And it's throwing me off. Because I'm used to it being in the center of my screen. I digress. Okay, this is the G-ball, gravity ball explanation to this lab. This is the newest lab. It is awesome. So, you're going to get a ball. This is our quick explanation, then I'll go over this page. You're going to get a ball. It looks like a softball. It's about the size of a softball. It's got a little button on it. When you push the button, nothing happens. But when you release the button, a timer starts. And as soon as it hits something hard, the timer stops, right? So, what's the point of that? Great question. So the point is, you push this button and you drop it. And then it'll stop and it'll tell you how long it took for it to hit the ground from whatever distance it's dropped. Couple things to note, and it'll be on here too. We want to drop it on a not so hard surface because it can break even though it's meant to be dropped, right? So if you're dropping on like a hard tile floor or something like that, or for a really high distance, put like a towel down or something, like a couple inch thick towel. That way it hits and stops, but it doesn't just disintegrate, right? So with that being said, let's go over this lab. I'm going to go over it loosely because I want you guys to do it, right? So that's kind of like what we talked about. The first thing you're going to do is determine the value of G. Well, we know that G is going to be our constant, which is gravity. It's gravity on Earth, right? Should be about 9.8 meters per second squared. But we're going to verify that. So how are we going to verify that? We are going to use the formula they set here. Gravity equals, ooh, I got a bunch of stuff on my screen, 2 times distance divided by time squared. And it's going to be our average time squared because they're going to take a couple different ones. So, first thing, what do we do? So let's just look at this first one. You're going to hold it a distance of a half a meter, so you'll need a meter stick. Measure about a half a meter tall. You're going to push the button and drop it, and it'll hit the floor and the time will stop. Record your time. Do that 3 times. This is the average for a half meter, right? Then you're going to do it for 1 meter. It's going to 1 meter tall. Hit the button, let it go, drop it. Do that 3 times, take your average. So do that for these. This is you're going to calculate the average with this formula. So first off, that's a weird formula because it's not quite the formula we normally use. So it is gravity equals 2 times displacement divided by, I don't like to put divided by a slash. It annoys me. Time squared, right? So let's rewrite that in the formula that we've been normally using. So essentially, gravity is going to be our acceleration of y. I don't like that they say g, I like acceleration of y. And they're messing around with this formula. Let's see if this formula is the same as that other formula. So normally, our displacement of y is 1/2 acceleration of y times time squared. So why are they giving us this weird looking formula, right? Let's see if it equals the same thing. So if we were to rearrange this formula, we do times time squared. This whole side cancels that out, so time squared. So then essentially, I'm going to change this g to acceleration of y, just FYI. Essentially, we have acceleration of y times time squared equals twice the displacement, right? So now what I'm going to do is I'm going to say, I'm going to divide this 2 out, divide this 2 out. So I'm going to flip it just because I like the single things on the left. Displacement equals acceleration of y times time squared divided by 2. Now, what's the exact same as dividing something by 2? Multiplying something by half, right? So I'm going to rewrite it one more time. Displacement equals 1/2 acceleration of y times time squared. Exact same formula we've been using, right? So they rearranged it for us. Awesome. Thanks, guys. But there we go. So with that being said, you're going to do your times. Your average time is going to go here. And then you're going to use your formula. However you want to set it up, it's all the same to me. Do this one because that's what you're trying to find. They already set it up for you. Use this formula to find the gravity at each distance. So this one, your D is going to be 0.5. The second one, your D is going to be 1, right? Third one's going to be 1.5, da-da-da-da, so forth, right? They just want you to verify that the force of gravity is the force of gravity, which it should be 9.8. meters per second squared because it's an acceleration. They want you to verify that. Obviously, it's not going to be exact when you do this because, as they said in this very wordy paragraph here, there's friction there with the air, there's wind, all kinds of weird variables that may get us slightly off, but they just want you to verify that. All right, so you're going to get your average gravity. That's all these. Take the average, add them all together, divide by 4 because there's 4 of them. And then you are going to, I didn't read this in advance, so we're just going to YOLO this. Height of the stairwell. If there's a stairwell nearby, you're actually going to do it in the stairwell. You go down the hall. Should be to our current, well, you know where the stairwell is. It doesn't really matter which one you're going to do. What you're going to have to do, though, is you are going to, what do they want you to do? If there's a stairwell nearby, you drop a blanket, time, and use time. All right, so you're going to find the height of the stairwell, height, by using your formula for displacement, your displacement of y formula. So in this case, you'll want to use this style because it's a little unclear, but yeah, because it's set up in what we want. So first thing you're going to do is drop the ball. Use something soft for it to land on because it will break because it's a tall stairwell. And then after that, and also remember how high you drop it. So like you raise your hand up here, is it down? Because that's important, right? So after you do that, calculate the displacement, the height of the stairwell. And then what you're going to do is you're going to have to get a string and have somebody else come help you out. Hold the string and have it go all the way down, just pull it tight and then touch the floor. And then sort of like mark it where it is, and you're going to have to measure the length of that string. In other words, you want to verify how high the stairwell was and compare that to the number you calculated, right? So, pretty cool stuff. So that's your time. You'll get that from the ball when you drop it. This is your displacement, which you're going to calculate. And then this is you measuring it directly. So this should, and then you're going to compare these two, what you calculated to what you measured. It's actually a freaking awesome lab. So that's cool. And then how do you explain the difference? And you're just going to, that's it, explain the difference. And then this is just a little question deal. There's actually a Mythbusters deal. I think I have it on Canvas where they fire a gun and then they drop a bullet. And they're both the exact same height, right? And they see which one hits the ground first. And you don't have to see the result, but what they want you to get is that X and Y, in terms of projectiles, are independent of one another. So X and Y can, how do I explain that? They're independent. So it doesn't matter how fast something is going along the X-axis, it's still going to fall at the same rate, right? So anyways, this is an awesome lab. Hope you guys like it. Hopefully this explains it. Let me know if you guys have any questions.